Okay, today we're going to look at tree diagrams, tables, and outcomes. So first we'll talk about a single stage experiment. When we're talking about combinations or probability, the word experiment has a slightly different meaning than it does in the sciences. Experiments can range from very simple, flip a coin, to very complex, count the number of uranium atoms that undergo nuclear fission in a sample of a given size over the course of an hour. Experiments have unknown outcomes that generally rely on something random, so that if the experiment is repeated or replicated, the outcome might be different. No matter what the experiment is, analysis of the experiment typically begins with identifying its sample space. Sample space of an experiment is a set of all possible outcomes of the experiment, so it's often expressed as a set. In other words, a list bound by braces. The experiment is randomly select a number between 1 and 4. Our sample space would be the set containing 1, 2, 3, 4. So let's find the sample space of each experiment. You draw a card from a standard deck and note its suit. So, what are the suits of a standard deck? We have what? Heart, club, spade, and diamond. So that is our sample space. You draw a card from a standard deck and note its rank. Well, what are the ranks? We have a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, a king, and an ace. You roll a 4-sided die and note the number on the bottom. So with a 4-sided die, we're going to assume each side is numbered 1 through 4. So our sample space would be 1, 2, 3, 4. You roll 3 4-sided dice and note the sum of the numbers on the bottom. So this gets a little more complex. Because we could roll a 1, 1, 1, a 1, 1, 2, 1, 1, 3, and 1, 1, 4, which would give us 3, 4, 5, and 6. And essentially, this is rolling a 1 or 2 1s and one other number. We could roll. So we're looking at our set. Let's try this way. 3, 4, 5, and 6. So a 1, 2, 1 would give us the same thing. A 1, 2, 2 would give us a 5. A 1, 2, 3 would give us a 6. A 1, 3, 2 would give us a 6. A 1, 3, 3 would give us a 7. A 1, 3, 4 would give us an 8. So we're really just going to cover everything. If you think about this, what is the highest possibility? 4, 4, 4. So we're looking at 12. I'm going to do 4, 4, 3 and get 11. 4, 4, 2 and get 10. And 4, 4, 1 and get 9. So essentially, our sample space is going to be our lowest possibility, which is 3, and our highest possibility, which is 12, and everything in between. So that's what you call a multi-stage experiment. Some experiments have more complicated sample spaces because they occur in stages. These stages can occur in succession, like drawing cards one at a time, or simultaneously, like rolling 2 dice. Sample spaces get more complicated as the complexity of the experiment increases. So it's important to choose a systematic method for identifying all the possible outcomes. First method we discuss is the table. Tables are useful for finding the sample space for experiments that meet 2 criteria. The experiment must only have two stages, and the outcomes of each stage must have no effect on the outcome of the other. When the stages do not affect each other, we say the stages are independent. Otherwise, the stages are dependent, and so we can't use tables. We look at the method for analyzing dependent stages soon. So decide whether the two stages in these experiments are dependent or independent. You're getting dressed to go to a party and you plan to wear a blouse and a skirt. You choose the blouse first, then the skirt. Seem that you'd be comfortable wearing any of your skirts with any of your blouses. So does the blouse you pick affect the skirt? Or does the blouse you pick affect the skirt? No. So these are independent. On further reflection, you realize that some of your skirts clash with some of your blouses. So you choose the blouse first and then choose the skirt that goes with your chosen blouse. These would be dependent because the effect on which blouse you pick is going to affect which skirt you pick. You're going to pick one that goes with it. If you have a two-stage experiment with independent stages, a table is the most straightforward way to identify the sample space. You build a table, you list the outcomes of one stage of the experiment along the top of the table, outcomes of the other stage down the side. Cells in the interior of the table are then filled in using the outcomes associated with each cell's row and column. So let's look at an example. Use a table to identify the sample space of an experiment in which you flip a coin and roll a six-sided die. Or a six-sided die can be 1, 2, 3, 4, 5, or 6. And our coin could be head or tails. One head, two head, three head, four head, five head, six head. One tail, two tail, three tail, four tail, five tail, and six tail. So there we have our sample space. Next concept we can use is what's called a tree diagram to identify sample spaces. In experiments where there are more than two stages or where the stages are dependent, a tree diagram is a helpful tool for systematically identifying the sample space. Tree diagrams are built by first drawing a single point or node. Then from that node, we draw one branch, a short line segment, for each outcome of the first stage. Each branch gets its own node at the other end, which we typically label with the corresponding outcome from that branch. From each of these, we draw another branch for each outcome of the second stage. Assuming the outcome of the first stage matches the branch we are on, there are other stages we can continue from there by continuing to add branches and nodes. So you have a modified deck of cards containing only the Jack, Queen, and King of Hearts. You draw two cards without replacing them, where order matters. Use a tree diagram to identify the sample. Well, our first stage, we start here. We could get a Jack, a Queen, or a King. Now, if I get a Jack, the second card can only be a Queen or a King. If I get a Queen, the second card can only be a Jack or a King. And if I get a King, the second card can only be a Jack or a Queen. So my sample space is Jack, Queen, Jack, King, Queen, Jack, Queen, King, King, Jack, King, Queen. And that finishes up tables and trees.